we're asked to multiply and express as a simplified rational. So when you multiply any rational expressions, it's just like multiplying any fractions. You multiply the numerators times each other and the denominators times each other. So if we multiply the numerators here, and when you're just multiplying a bunch of numbers, it doesn't matter what order you do them in. And so we want to multiply in an order that makes it a little bit clearer. So we can multiply the coefficients first. So we can multiply 3 times 14. 3 times 14 gives us 3 times 10 is 30. 3 times 4 is 12. It gives us 42. So that's the 3 and the 14. Then we have an a squared, 42a squared. Then we have a b. I'll write these in the order that the letters, in alphabetical order. And then we have an x squared. And then we have an x squared. So I just changed the order, but I just multiplied all of these things in both numerators. So that's the numerators multiplied. And let's do the same thing for the denominator. So I'll first do the constant, or I should say the coefficients. So I'll multiply 2 times 18, which is 36. And then I have an a over here, just one a, 36a. Then I have just one b over here, times b. And then I just have one x over here, times x. So we've multiplied the two, and now we just need to simplify them. So let's just think about this a little bit. Both 42 and 36 are divisible by 6. That's their greatest common divisor. So let's divide both of them by 6. 42 divided by 6 is 7. 36 divided by 6 is 6. Both a squared and a are divisible by a, so let's divide them both by a. A squared divided by a is a. A divided by a is 1. And just remember, I'm just dividing in any of these steps, I'm just dividing the numerator and the denominator by the same number. And that's not changing the overall value of the expression. And then I have a b divided by a b. Well, I can divide both the numerator and the denominator by b. And so I will those two characters will cancel out to just 1 and 1. Don't even have to write it. When you multiply by 1, it doesn't change the value. And then I have an x squared divided by x. They're both divisible by x. X squared divided by x is x. X divided by x is 1. So in the numerator, we are left with 7ax. We can ignore the b because it's just multiplying by 1 now. So we have 7. I'm doing that same shade of green. We have 7 times a. 7 times a times x in the numerator. And then in the denominator, we have 6 times 1 times 1 times 1. So we have all 6's. Now I want to be a little bit careful here, because if we want this expression, so we have done what they've asked us to do, but it begs a little bit of a question here. If we want this expression to truly be the same expression as the product of these two things, we have to constrain its domain. We have to constrain the variable values here. Because this expression right over here, this is defined for any a's or x's. You could put any a or x here, and you will get a value here. But this product over here, this was not defined for any a's or x's. The b's cancel out, but it was not defined for any a's or x's. In this situation, if either a or x equaled 0, this expression right over here would be undefined. In fact, if b was equal to 0, this expression would also be undefined. So if you really want this to be the exact same expression, if say this was a function definition, if you wanted it to be the exact same function definition as this over here, you would have to have it have the same domain. So I'll just write down the domain here. They need to have the same domain if you want them to be the exact same function. If you don't care about that, then you could just say, OK, let's just go with this. But you should constrain it if you want it to be an equivalent expression. And so in either case, you should constrain the domain to be all real numbers. All real numbers. And this is a little bit different because this is essentially like a two-variable function if you view a as a possible variable here. So all real numbers for a and ab and x, except a, b, or x is equal to 0. So we're just saying that a, b, and c can be anything other than 0. And we're getting it from our original expression after we multiplied. And we're saying if this needs to be the same, it has to have the same domain. Most algebra classes, they won't make you be this particular about it. They'll just say simplify the expression, and you'll just simplify it, and you'll give this answer. But if you really wanted it to be the exact same expression, you would really have to have the same domain.